Welcome to Study Loop.
Okay, this is Chapter 11, Section Problem 88, and it asks us to draw a heating curve, such as the one in Figure 11.33, for 1 mole of benzene beginning at 0 degrees Celsius and ending at 100 degrees Celsius. So it wants us to assume that the values given here are constant over the relevant temperature ranges, so just draw straight lines. Okay, so that's what I've done here. We can see the values included in the textbook. And figure 11.33 kind of looks like this, where, they started below the freezing point and ended above the boiling point, and they calculated the energy at the different stages and the total energy, and they tried to include the slopes as representative of the amount of energy required to go through the different stages. So that's what I've tried to do here. Okay, so for steps 1, 2, 3, 4, and 5, going from 0 to 5 degrees Celsius, that's going to be in the solid stage, and the energy required to heat that is calculated by the specific heat of the solid, so 118 joules per mole per K. And throughout this whole calculation, we're assuming 1 mole. Okay, and so, if you just multiply, the delta T there is 5.4 degrees Celsius, and the delta Celsius and delta Kelvin are the same. So we can multiply that to calculate 637 joules to heat that. And then we've got a plateau that would be present during the melting of the benzene at 5.4 degrees Celsius. And then we have the third segment, which is the heating of the liquid. And what we can see here is we just conceptually, if this has a higher value for the specific heat than the other two states of matter, that means it takes more energy to heat it per degree or per Kelvin or per degree Celsius. So this should have the lowest slope. And then for section 4, again, it's going to be a longer plateau to go through this phase change, going from a liquid to the gas, than from the solid to the liquid, because the enthalpy of vaporization is higher than the enthalpy or the heat of fusion, right? So it takes more energy to convert each molecule that's in the liquid phase to the gas phase than the previous step. So that's represented on the graph as a longer plateau. Finally, in section 5, we have the steepest line here, because it takes the least amount of energy to raise it by a degree Celsius. And we can see these different calculations that we're also able to obtain simply by multiplying the specific heat by the temperature change, and also the heat of fusion and the heat of vaporization, because we're assuming 1 mole of each of these, or 1 mole of benzene. We'll just use those values directly. This is wrong here. This is it should say joules here. But other than that, this is just joules. Other than that, that's how you would do this particular problem. And again, it's a mix between a conceptual problem and a calculation. This is what you have to do in these kind of thermodynamic calculations, where you add up the different segments of that are represented by these lines, because it takes a different amount of energy to raise the benzene in its solid state versus the benzene in its liquid state versus in the gas state. And this is a good way to conceptualize it. Anyway, good luck studying.